Hello, my dear mechanical engineers. Myself, Chandrasekhar, welcoming you all to this beautiful session of fluid mechanics and heat transfer numerical practice. The session is very important for those who are going to appear in BARC 2023 examination. And the difficulty level of the questions is at par with the actual difficulty level of the BARC exam. So a very good evening all of you, and a very warm welcome to you all to this session. Please do join me fast, and those who are already here, please respond through the comment section if my audio and visual quality are fine or not. Am I audible and visible to all of you? Yes, no one. Good evening, Roshan, Namaskar, Adab, Shubh Sandhya. I hope everyone is safe and sound. So there will be around 12 questions, and we will practice those questions. I want you guys to respond through the comment section, and if through the numerical practice we will improve our fundamentals, we will improve our basics. All right, so shall we start? All right, let us start then. Before I start, this is my quick introduction. I am having more than 10 years of teaching experience in the field of GATE, IES and PSU. A mechanical engineering graduate from IIT Delhi, cleared engineering services exam also, and I have worked in SAIL for a couple of years, and I am quite comfortable in the mentioned subjects of mechanical engineering. So today's session is all about the fluid mechanics and heat transfer. These topics are very important from any competitive examination point of view, as well as these are fundamental or basic subjects of mechanical engineering, and there is a close connection between these two subjects as well. So not only from examination point of view, the subjects are important from the interview point of view as well. All right, if you have anything to discuss, if you want to connect with me, you can use the mail ID, official mail ID, which is there on the screen, and you can join me on the Telegram as well if you are not part of my Telegram group yet. That is Mechanical by Chandrasekhar, and you can use the link to join the Telegram. All right, so please do keep your pen, notebook and calculator, and try to solve the question with minimum time frame and share your answer in the comment section. So that is what you require, and if you have any doubt, you can just raise your concern through the comment section. Are you all ready? Please give me thumbs up quickly, and do not forget to like this session, guys. It is my humble request, because the more you like, the more you share the session, it reaches to the maximum audience, those who are going to appear for the BARC examination, and it will be helpful for all the aspirants to have the better preparation. So please do share this session and subscribe our BYJU'S YouTube channel. So the last one information I would like to share with you. There will be a free workshop going to happen on 21st of March. All those aspirants who are going to appear for GATE 2024 exam. So how you can crack the GATE examination with the single or 2-digit rank. So Joshit sir will be sharing his experience, his expertise to have the better and efficient preparation to clear the GATE exam. The workshop is completely free, and you can register yourself to the workshop, and do share this information also with all your friends and colleagues. The timing will be 7:30 p.m. All right. So let us start with the first question. Please, everyone, I want everyone to respond. Then only it will be fun learning. Otherwise, it will become monotonous. Question number 1 is on your screen. Question number 1 from the fluid mechanics basic, simple, conceptual, and theoretical question. Yes, every one of you, please do let me know the answer. Which property of mercury is the main reason for its use in barometer? Barometer are the instruments measuring the atmospheric pressure. The barometer is the instrument which is used to measure the local atmospheric pressure. There is a difference between barometer and manometer. Manometer is the instrument used to measure the pressure of any fluid, pressure at any point in the fluid. But barometer is specifically designed to measure the atmospheric pressure. And the barometric fluid is supposed to be mercury only because of some reason. What is the reason? What is the important reason for which barometer is taken as the mercury is taken as the barometric fluid because the mercury is having very low vapor pressure. Vapor pressure of mercury is very low, or we can say it is having high saturation temperature. The mercury is having high saturation temperature or low vapor pressure. That is the reason it is difficult to vaporize the mercury. Mercury does not get vaporized. That is the reason the reading of the barometer becomes more and more accurate. That is the primary reason. The secondary reason can be high density. But if it is MCQ, the option C is the correct answer. Well done, guys. No one, Roshan, Mohan, Parth. Every one of you, please do share your answer. Let us move to question number 2. Quickly, what is the pressure inside a soap bubble? Find out the value of pressure in a soap bubble over the atmospheric pressure, means the extra pressure. The pressure difference between the soap bubble to the outside pressure. If the diameter of the soap bubble is 2 cm and the surface tension for the soap solution is 0.1 Newton meter. Yes. What is the answer to question number 2? Soap bubble is having 2 interfaces. And due to 2 interfaces, there are 2 interfaces. Inside there is air. Soap bubble is having 2 interfaces. It is a thin interface, thin liquid surface. There is air inside, there is air outside, and there is a liquid film. That is how soap bubble is developed. What is the answer to the next one? Are you able to hear me? Yes. So delta P, pressure difference between inside and outside pressure. Pressure inside minus pressure outside. For a soap bubble, it will be 8 sigma by diameter. The pressure difference between inside and outside is 8 sigma by d. Sigma is given as 0.1, formula based. But you should remember the formula, that is 8 sigma by d. 8 into sigma is 0.1. What is the diameter? 2 centimeter. That is 0.02 meter. Is the value of pressure difference in Pascal. If you put all the parameter in their SI unit, then only you will get the answer in SI unit. What is the answer? Is it C, Abhi, Parth, 4 sigma by R, or 8 sigma by D? Yes, you can also memorize it, 4 sigma by radius. But if it would have been, so answer is C. C is the answer. 40 Newton per meter square you must be getting. 8 into 50. Sorry, 8 into 5. 8 into 5. If it would have been air bubble, try to understand the difference. Air bubble and liquid drop. If it would have been air bubble or liquid drop, it is a single interface. It is having one interface. Air bubble or liquid drop is having only one interface. Don't go with the bubble. Sometimes the question can be framed for air bubble. For air bubble, it is like liquid drop. So for air bubble or liquid drop, it will be 4 sigma by D or 2 sigma by R, because it is only one interface. Air bubble is what? Air bubble is there is air outside, there is liquid, air inside and there is liquid outside. All right. So the answer to the question number 2 is option number C. Well done, guys. Well done. I see a lot of students have already joined. So please do respond. Please do mark your presence by writing in the comment section. Share your answer, share your doubts. Keep on talking to me and your friends in the comment section. What is the answer to the next question? Question number 3 on your screen. The pressure reaches a value of absolute 0. When does the absolute pressure become 0 Pascal? When is the absolute pressure becomes 0 Pascal? Absolute pressure becomes 0 Pascal when the absolute temperature becomes 0 Kelvin. And this is impossible to achieve. Why it is impossible to achieve? Because the molecular activities at 0, absolute 0, molecular activities or molecular motion stops. Or molecular motion stops. At absolute 0, molecular activities, molecular motion stops. So when the molecular momentum of the system becomes 0, molecular velocity becomes 0, then only absolute 0 is achieved. At a temperature of minus 273 Kelvin, that is incorrect. It is 0 Kelvin. under vacuum condition. What is vacuum condition? What is vacuum? Vacuum is when the absolute pressure is less than, sorry, gauge pressure is less than, or gauge absolute pressure is less than atmospheric pressure. Absolute pressure is less than atmospheric pressure, or gauge pressure is negative. That is called as vacuum condition. So that is also incorrect. At the earth center, that is also incorrect. So the correct answer for question number 3 is D, isn't it? Can we proceed further? Question number 4. The question is from buoyancy and flotation, formula based or memory based question. How is the metacentric height GM? Metacentric height is used in floating bodies. That is used in floating body, partially submerged body. Metacentric height is the parameter which is used to check the stability condition. What type of equilibrium the floating body attains, whether it is rotationally stable, neutral, or unstable. So what is the answer to this one? Question number 4. Question number 4. Every one of you, please respond. GM is equal to IV. What is GM? GM is BM minus BG. BM minus BG. Sorry, BM minus BG. The distance, the difference between BM and BG is called as metacentric height. What is BM? That is I minimum upon volume of the fluid displaced minus the distance between B and G. That is how we can calculate the metacentric height. That is how we can calculate the metacentric height. I is the moment of inertia of the plane, means the horizontal section of the floating surface at the water surface. V is the volume of the body submerged in water, that is volume of the fluid displaced, and BG is the distance between the center of gravity G and the center of buoyancy. And when GM is coming out to be negative, then what type of equilibrium it is? It is rotationally unstable. If GM is coming out to be 0, then it is neutral type of equilibrium, isn't it? Neutral. And if it is greater than 0, yes, most of the questions will be simple. It is all about the question selection. There will be tough questions as well, but if you will select the tough questions, then you might end up getting the problem with the time management. So those questions which looks easy, simple, direct, you should solve those questions first, and then if time permits, then you solve the remaining question. If GM is greater than 0, then it is a stable type of equilibrium. All right. So GM, metacentric height, is very, very important parameter. GM is the deciding factor, deciding parameter in the floating body. So the short trick you need to remember is MAG. When the metacenter is lying above center of gravity, then the floating body is rotationally stable. All right. Let us move to question number 5. Question number 5. So we will bring all type of question. Parth, Saurabh, we will bring the tough questions as well. So there will be a mix of questions actually. If your fundamentals are clear, then you will find each and every question easy. But if your basics are not that much clear, then it becomes difficult. So the difficult or easy is actually the relative term. The pressure in Pascal corresponding to 3 centimeter column of mercury is. What is the answer? So those questions which look simple to you, please do solve them as quickly as possible. The pressure in Pascal corresponding to 3 centimeter column of mercury. If the height of mercury is 3 centimeter, so what is the pressure which is exerted by 3 centimeter? So conversion of pressure into the pressure head, H will be equal to P by rho G. That is how we can write the pressure, or we can convert the pressure in terms of pressure head. This is called as pressure head in terms of fluid. And if you want to find out the pressure in Pascal, then we can use rho into G into H. So pressure in Pascal, rho of mercury is 13,600, G is 9.81 and H is 3 centimeter, that is 0.03. If you put all the parameter in the SI unit, then you will get the answer in SI unit, that is Pascal. What is the answer to question number 5? 3994.3. Are you getting option B? Yes. Kiran, Saurabh, Novan, Roshan, Parth. Well done, guys. Well done. Keep it up. And after this session, please go through the description link also, description box also. There are important links there in the description box. How to enroll yourself for the workshop, register yourself for the workshop, and you can download or you can get the free ebooks for your preparation also. Let us move to question number. What is this question number 6? We are halfway. Question number 6. It is just kind of the mind relaxing activity. That is why I have kept the question simple, so that you develop the confidence, you develop the motivation, and it relaxes your mind as well. You should be able to get the concept quick. Just after reading the question, you should get your concepts in the mind. A centrifugal pump delivers a manometric head of 12 meter when pumping a liquid of relative density 0.8. Relative density is also called as specific gravity. If all the other factors remains the same, but the liquid is changed, which is having a relative density of 1.2 meter, then the new manometric head will be. So the pump is used to raise the pressure. It is used to increase the pressure, and that is why the discharge will be delivered. By raising the pressure, by increasing the pressure of the fluid, the discharge gets delivered. That is how the centrifugal pump works. And centrifugal pump works on the rotatory motion, rotation of the impeller. That is how, due to the centrifugal action. There are two types of pumps. One is centrifugal pump, another is reciprocating pump, right? So if the pressure rise is same, delta P, for delta P to be same, the rise in pressure same. So we can say rho1 H1 is equal to rho2 H2. That is conversion of one fluid column into another. That is how conversion. Hi Ganesh, welcome, good evening. The conversion of one fluid column into another can be developed, or we can write it as S1 H1 is equal to S2 H2. If we divide by density of water in the left hand side as well as in the right hand side, so it will become S1 H1 is equal to S2 H2. For the same pressure rise, S1, that is 0.8 into H1, that is 12, is equal to S2 specific gravity 1.2 into H2. That will be the new manometric head. So it will be 0.8 upon 1.2 into 12 is equal to H2. What is the answer? 8 meter. Option A. Option A will be the answer. The question is not actually from the centrifugal pump. So sometimes you may find the language of the question such that you might think the question is from a different topic. But if you read the question clearly, if you understand the question concept, then you will understand whether a particular question is from which topic. The next one, question number 7. The next one on your screen. Find the answer to the next question. An isosceles triangular plate of base 3 meter and altitude height 3 meter is immersed vertically in an oil. It is not water, it is oil of specific gravity 0.8. The base of the plate coincides with the free surface of the oil. The center of pressure will lie at a distance of from the free surface. What will be the answer to this one? Every one of you do the calculation part and bring me the solution through the comment section. All right. And if anybody is having any doubt, any special type of session, if you want, you can just suggest through the comment section what type of session you want to clear the BARC examination or to clear any other competitive examination. If you want the theoretical type of session, if you want the numerical practice type of session, what will be your requirement? Accordingly, we will plan the sessions for your benefit. There is an isosceles triangular plate, base 3 meter and altitude 3 meter. The plate is kept like this. This is how the plate is kept, right? This is the free surface. This is 3 meter. And the height is also 3 meter. It does not matter whether it is isosceles or not. So the depth of CP from the free surface, that is HCP, is how much? One thing, those who have studied fluid mechanics from me, they must be knowing a short trick. If the base of the plane surface coincide with the free surface, then we can find out x bar. What is the value of x bar? That is the depth of centroid from the free surface. X bar is equal to 1 by 3 into h, isn't it? X bar is equal to 1 by 3 into h. And if we want to find out HCP, the depth of CP, then we can add 1 in the numerator and we can add 1 in the denominator. So that is the depth of CP from the free surface. So it is 2 by 4h or h by 2. That is the direct method or using the short trick. So h by 2, what is h? 3 by 2, 1.5 will be the answer. The another approach is to use the formula for a plane surface, vertical plane surface. HCP is x bar plus Ig by Ax bar, isn't it? Put the values. This is 3 meter, this is also 3 meter. So x bar will be equal to h by 3. This is 1/3 of h. This will be 2/3 of h, right? So x bar is equal to h by 3, 3 by 3 plus Ig bh cube by 36 into area half into b into h into x bar, that is 3 by 3. X bar is 1. X bar is 1. So if you do the calculation, 1 plus this 3 will get cancelled out, isn't it? So it is 3 into 3 into 2 upon 36. 18 by 36. So 1 plus 18 by 36 or 1 plus 1 by 2. That is 1.5 meter. That is how you can get the answer as well. Option C is the correct answer. Let us move to the next one. Question number 8. Question number 8 on your screen. There are 12 questions in total. So we will try to finish the session at the earliest because the time is very crucial. You should have the revision also. You should continue doing your practice. Yes. The question is from model analysis. Very, very important topic. Model analysis. In a 1 in 50 model of a spillway. Spillway is a structure for the controlled release of water from the dam. That is the spillway. And in spillways, the gravity is important. The gravity force is important. And when the gravity force is important, it is the Froude number which is to be used. So what is the Froude number? The ratio of inertia force by gravity force and then under root. So it will be V upon under root of L into G. That is the Froude number. We have to equate the Froude number for model and prototype. We have to equate the Froude number for model and prototype. V upon under root of LG. G is taken constant. G is taken constant. So for Froude number, if we equate the Froude number, then we can say V is directly proportional to root L. V will be directly proportional to root L. But the question is the discharge in the model QM is given. What is the corresponding discharge in the prototype? That is the question. So we can say Q is equal to pi by 4 d square into V. So Q will be proportional to d square into V. Or we can say Q is proportional to L square into V. Diameter is the dimension of the diameter is L square into V. Or we can say Q is proportional to L square into root L. If you are able to develop this relationship L to the power 5 by 2 or 2.5, then we can say QP by QM is equal to LP by LM to the power 2.5. That will give. What is LP? This is the scale ratio. So LP by LM will be equal to 50 by 1, or LM by LP will be, prototype is a bigger part, model is a small scale replica. LM by LP will be 1 by 50. So we can say QP is equal to QM is given 3 meter cube per second into 50 to the power 2.5. That will be the answer. What is the correct answer? Are you getting option 53033 meter cube per second or not? Isn't it? Option C is the correct answer for question number 8. Now these were the questions from the fluid mechanics. Let us have some questions from the heat transfer as well. And as there is a scholarship test also on 19th, I think. So you register yourself for this scholarship test, and based on your performance in the scholarship test, you will be able to get the benefit, or you will be able to get the discount in our various courses, like the classroom courses as well as the test series. So do register. It will be important, or it will be beneficial for you all. Let us move to question number 9. From the question is from the heat transfer radiation shape factor. Radiation shape factor. There is a small sphere. There is a small sphere of outer area 0.6 meter square. Let me call the sphere to be 1. So A1 is equal to 0.6 meter square. That is, sphere is insulated from inside. That is why it is talking about the outer area. Totally enclosed by a large cubical hall. It is enclosed by a cubical hall like this. And the cube is insulated from outside. That is how the radiation exchange will take place. That is surface 2 lattice. I am calling the cube to be surface 2 and the sphere as surface 1. The shape factor of hall, that is 2, with respect to sphere, that is 1. F221 is given as 0.004. What is the measure of internal side of the cubical hall? Let me call it as A. What is the internal side of cubical hall? What is your answer? Question number 9. Yes, every one of you, tell me the answer. Question number 9. You could have called the sphere to be surface 2 and cube to be surface 1. Your choice. So in that case, F122 would have been given to you 0.004. 1 is, I am calling 1 to be sphere and 2 to be cube. What is the answer? So F221, can we call it as A1 into F122 upon A2 from the reciprocity theorem? Using the reciprocity theorem, A1 is known to us. A2 can be written as 6 into A square, isn't it? If the side of a cube is A, so A2 will be 6A square. We need to find out the value of A. And what about F122? So can we use the enclosure theorem? If it is a closed curve, it is an enclosure. So according to that, then according to enclosure theorem, F11 plus F122 is equal to 1. And what is the self shape factor of the sphere? If the sphere is insulated from inside, it makes the convex surface, and for a convex surface, self shape factor will be 0 because the radiation always travel only in a straight line. So F122 is equal to 1. If we put this value, then we can say F221, that is 0.004, is equal to A1 by A2. Isn't it? And what is A1? 0.6. What is A2? 6A square. So it will be 1 by 10. It will be 1 by 10 A square. So if we multiply this, so 0.04 into A square is equal to 1. So A square is equal to 1 upon 0.04. That is 25. And A will be equal to root of 25. That is 5 meter. The value of A will be 5 meter. Isn't it? Option B. B is the right answer for question number 9. B will be the correct answer. Yes, Parth, Saurabh, Roshan, well done. Kiran. Yes, yes, everyone. Again, memory-based question. In PSUs, you can expect the memory-based questions. The difficulty level of PSU is little lesser than the GATE exam. So you may find the straightforward question. Which one of the following expresses the thermal diffusivity of a substance? Heat transfer ability. What is thermal diffusivity? That is the heat transfer ability. And the thermal diffusivity, that is alpha. Heat transfer ability. Alpha is more for gases, then liquid, and then solid. This is the order for thermal diffusivity. And what exactly is the thermal diffusivity? Thermal diffusivity alpha is the thermal conductivity, the ratio of thermal conductivity of the material. How fast heat can penetrate in a given material. Thermal conductivity upon heat storage capacity. That is rho into C. That is the formula. What is the unit of thermal diffusivity? What is the unit of thermal diffusivity? It is meter square per second. M0 L2 T minus 1. So it is K by rho C. K by rho C. Even though the thermal conductivity of gases are less than the thermal conductivities of liquid, but still alpha for gas is more. The gases are having more heat transferability. Gases are having more momentum transferability. There is another parameter that is called as momentum diffusivity or kinematic viscosity. So the ratio of momentum diffusivity to the thermal diffusivity is very, very important number, dimensionless number, which connect the fluid mechanics and heat transfer. What is that called? Prandtl number. The ratio of momentum diffusivity to thermal diffusivity is called as Prandtl number, which is the connecting link between the fluid mechanics and the heat transfer. That is what I told you. There is a close connection between the heat transfer and yes, Pradeep, you are right. Let us move to the next one. There are two more questions to go. For free workshop also, Joshi sir is going to take the free workshop. You can register yourself through the link which is there in the description box. Let us move to question number 11. Second last question for the day. A furnace is made up of a red brick wall of thickness 0.5 meter and the thermal conductivity is 0.7 watt per meter Kelvin. For the same heat loss and the temperature drop, heat loss is same, the temperature drop is also same. This can be replaced by a layer of diatomite earth of thermal conductivity. This and what will be the thickness? What will be the thickness? What is the answer to this question number 11? Q in case of a plain wall. Furnace is a plain wall and the area of a plain wall remains constant. So Q is given by Ka delta T by L. L is the thickness. E is constant given in the question. Same heat loss and the area is same because it is in the form of a plain wall. Cylindrical and spherical systems are having variable area, but plain wall system are having constant area and delta T is also constant. So we can say K by L is constant. It is the question which is based on the relationship L is directly proportional to K. If you are able to develop this relationship, L2 by L1 is equal to K2 by K1. What is the value of L2, which is L1 0.5 into K2 by K1. What is K2? 0.14 upon K1, that is 0.7. So 0.5 into 0.2. 0.5 into 0.2. 0.1. 0.1 meter. B is the answer to this one. B will be the correct answer. Yes, Kiran, Saurabh, no one. Well done. And the last question for this session, and we will bring more difficult session as well. We will bring the conceptual sessions as well. We will bring the formula revision sessions also. All type of support we will provide you if you are ready to explore the opportunities, if you are ready to do the hard work to get the success, we are there to help you out in every possible way. The question is from the critical radius of insulation. There is an electrical cable of aluminum conductor. Thermal conductivity of aluminum is 240 watt per meter Kelvin. Cable means a cylindrical system. Is to be insulated with rubber. Insulating material is rubber. This is the insulating metal. Thermal conductivity is 0.15. The cable is to be located in air. The outside fluid is air, which is having the convective heat transfer coefficient as 6 watt per meter square Kelvin. The critical radius of insulation, RCR, critical radius of insulation for a cylinder is thermal conductivity of the insulating material. This is not required. The thermal conductivity of aluminum conductor is not required. It is the thermal conductivity of the insulating material, which is rubber, and to the convective heat transfer coefficient to outside fluid, which is in contact with the insulating material. So thermal conductivity of insulating material 0.15 and divide by 6. 0.15 divided by 6. What is the answer? So you will get option A. In millimeter, you will get 25. The question could have asked you critical thickness of insulation also. The question could have asked you, this is the critical radius of the insulation 25 mm. If the question asks you to find out the critical thickness of insulation, then RCR minus R naught. RCR is 25 minus what is R naught? It is not given actually. If it is not given, we cannot find out. But R naught, if it is given to you, the radius of the aluminum conductor, then you can find out the thickness, critical thickness of insulation. All right. So that is all from my side, guys. I hope you have enjoyed the session. It must have relaxed your mind to get yourself charged up to do more and more hard work in the coming days. So with this note, let me take your leave. अपनी आंखों में एक सपना बसा लो और उस सपने को पूरा करने में अपनी जी जान लगा दो. So with this note, let me take your leave. Stay safe, stay motivated, keep preparing with your full dedication and hard work. See you in the next session. Till then, enjoy, take care, have a good night. Shubh Ratri, Sabba Khair, Jai Hind. Thank you guys. Thank you for joining in.